Today we're going to be learning about the area of trapezoids, rhombuses, and kites. So the area of a trapezoid equals 1/2 times the height times by the quantity of our base 1 plus base 2. So using that formula, let's find the area of this trapezoid. The area equals 1/2 times by our height, which is 12 8/10, times by the quantity of base 1, which is 30 8/10, plus the base 2, which is 20 8/10. So if you want to solve this, take and add 30 8/10 plus 20 8/10, which is 51 6/10. And then we can multiply. So 1/2 times by 12 8/10 times by 51 6/10. The area is 330 24 inches squared. So here we need to find the area of this trapezoid. So we're going to use our formula. Area equals 1/2 times the quantity of base 1 plus base 2. So the area equals 1/2. We don't know the value of our height, so we're going to have to find that, but we do know our base 1 is 25 and our base 2 is 9. So let's find the value of our height. So if we look here, this is the height of our trapezoid. So if we take a look here, which is also the height, we can form our triangle. So we have 30 degrees. We don't know one of our legs, so we know the other leg is not 25, but this section right here is 9. So if the whole length is 25, we know this section is 16, so this is length of 16. So here we can use the tangent of 30 degrees equals the opposite divided by the adjacent. So here we can multiply, so the tangent of 30 times by 6, our height equals 3 46/100. So now we can take and write in 3 46/100 and for our height, and we can solve it. So the area is 1/2 times by 3 46/100 times by, we have 25 plus 9, which is 34. So our area equals 58 82 units squared. Let's find the area of this. If we take a look here in our figure, if we split it down right here, we now have two trapezoids. We have one trapezoid on the left and one trapezoid on the right. So let's first take a look at the left trapezoid. So we need to find the area of that left trapezoid. So the height is here on our trapezoid, and the height is 5 times by our bases. So one base is 5 plus the second base, and here's our second base, which is 9. So if we solve this, 1/2 times 5, 5 plus 9 is 14. So the area equals, well, if you do 1/2 times by 5 times by 14, the area is 35 units squared. So now we can look at our right trapezoid on this side. So if we do the same formula, the area equals 1/2. The height is again right here, so we're at the 90 degree. So we have a height of, starts at 6, goes to 9, so a height of 3. One base is 8. And we already know this base is 9. So 8 plus 9, we end up with 17. So the area equals 1/2 times by 3 times by 17. So the area is 25 5/10 units squared. So to find the area of our whole figure, we need to add the two trapezoids together. So 35 plus 25 5/10 is 60 5/10 units squared. let's look at the area of a rhombus or a kite. They both share the same formula, which is the area equals 1/2 times the diagonal 1 times by diagonal 2. So let's find the area of this rhombus. So the area equals 1/2 times diagonal 1. So our first diagonal here is going to be 18 meters because 9 plus 9 is 18. So we have times by 18. Second diagonal is 13.5 and plus 13.5 or 13.5 times by 2. So we know this whole diagonal is going to be 27 meters. So now we can find the area. So if we take 1/2 times by 18 times by 27, our area is going to be 243 meters squared for this rhombus. Take a look at this rhombus now. So we know we have one diagonal, and that one diagonal is 16. So now we just need to find our missing second diagonal. So we don't know the diagonal from B to D. Well, known by our properties of a rhombus, we know that they bisect each other. So this length is 8, and we have this length 8. So from A to the intersection, and then the intersection to C, they're both lengths of 8. So we don't know our missing leg there. So if we take a look at this triangle that's created, and redraw it out here, this is a 90-degree angle. We know from A to the intersection was 8, we know the hypotenuse is 29, but we don't know that missing third length. So we can use our Pythagorean theorem to solve this. We're going to square all of our sides and set them equal to the hypotenuse squared. So we have x squared plus 64 equals 29 squared, which is 841. Subtract 64 to both sides. So we get 777, and we square root 777. We're rounding to the nearest tenth, so we are finding that the missing side length is 27 9/10. So that means this side length is 27 9/10. So that means this length is also 27 9/10. So if we take 27 9/10 times it by 2, we know our diagonal from B to D is 55 8/10. So our second diagonal is 55 8/10, and now we can multiply. So 1/2 times 16 times by 55 8/10 is 446 4/10 units squared. Let's find the area of a kite ABCD. If BD, so the diagonal, is 48 centimeters, the length from A to B is 25, and the length from B to C is 26. So we are missing the second diagonal, which is from A to C. So we have area equals 1/2 times diagonal 1, which is 48, but we have to find our second diagonal. So we need to find the length of this part of our diagonal as well as our second one. So we need to look at first this top left triangle that was created to find our missing length. So since our whole length from B to D is 48, we know that each of these is 24. So that means that top left triangle has a leg of 24. We're missing our second leg, but we know the hypotenuse is 25. So we can use the Pythagorean theorem to find our missing side length. So 24 squared is 576, and 25 squared is 625. So if we subtract 576 from 625, x squared equals 49. So the last step to find that length is to square root. So x equals 7. So we know this length right in here is 7. So now we have to find the length of our y. So now we're looking at the top right triangle. So if I redraw my top right triangle, I know my one leg is 24. I'm trying to find my missing leg, and my hypotenuse is 26. So once again, let's use the Pythagorean theorem. So we have 24 squared plus y squared equals 26 squared. 24 squared is 576. 26 squared is 676. So when we subtract to both sides, y squared equals 100. And when we square root both sides, y equals 10. So if we know from A to the intersection is 7, and the intersection to C is 10, that means the diagonal from A to C is 17 centimeters. So our second diagonal is 17, so now we can multiply. So 1/2 times by 48 times by 17, we have the area of 408 centimeters squared.